So the idea of recursion is a function that calls itself. And if not implemented correctly, it will crash the program. For example, you don't necessarily have to type this because it's going to be broken. I'm going to write a function called call myself. It's going to print hi, and then it's going to call itself. And then down here, I'm going to call the call myself method function. And what that does, we've already seen functions before. It ignores this until it hits that, then it runs up here. It prints hello or hi, and then it calls itself again. And it's effectively in an infinite loop at that point, except it's worse than an infinite loop. The only thing about an infinite loop is it'll run forever, and you finally have to cancel the program. This will actually cause it to crash. Now, it may take it a while for it to crash, and so I might skip demonstrating that. Let's see if it does or not, reasonably quickly. Not really. Well, there we go, finally. It didn't take too long. Why is it crashing? Because each time a function is called, it has to allocate a little bit of extra memory, or maybe a lot of extra memory, in order to handle it. Then, once it returns from the function, that memory is released. So if our function looked like this, and this function was called boring, and all it printed was whatever, and it didn't call itself, then down here, when we called boring, it would hop up here, it would print that, and then it backs out. So it's like going into a room of a house. You have to allocate a little bit of extra memory as you go into the room. That's a really stupid simile. Anyways, as it goes in here, it has to allocate a little bit of extra memory. You know, and your computer only has so much memory in the program. Each program is only allowed to use so much memory. Nowadays they have, gigabytes, but still, there are limits. Runs up here, allocates a little bit, and then when it escapes, it frees the memory. Here it runs up there, it allocates a little bit, it calls itself, which allocates a little bit more, which calls itself, which allocates a little bit more, and so on. Never stops. So if you're going to do recursion, you have to provide a way for it to stop. You have to provide an exit point. And this isn't going to be on an exam, but it's a good computer science concept that I want y'all to have in the back of your brain for later studies. Recursion. When a function calls itself. A recursive function must have a way to return, or else it will call itself forever and crash. Eventually run out of memory. Which is even worse than an infinite loop. I'm using the term infinite loop. We know what one is, right? It's a loop where the case never becomes false. If I do this, x is equal to 1, while x is equal to 1, parentheses not necessary, print, yep. It's just going to do that forever because nothing ever changes the value of x. There's a couple ways to handle exiting a loop. One is to change that x variable so that it's no longer true. Another is providing a break statement which interrupts the while loop. And the third is a return statement. If you had a loop inside a function and you if you put a return statement inside that loop, then it would bail out. It wouldn't finish running the loop. So that's an infinite loop. It's bad, but at least it doesn't crash the computer because the programmer can, the user can find the X box, or at the very worst, they can go to the task list, the process list, wherever that is nowadays. Start Task Manager. You see all the programs that are running. Chrome always looks like it's running 1,000,000 times. So anyways, that's recursion. What is it useful for? Well, I'm going to show you a use of the recursion idea that does something that you could do just as easily with looping. I'm going to have to mess all this up just a little bit, so I guess I'm going to just comment it out. The ultimate infinite loop is just to do something like this. While true. Do something. Yeah. You know, print. Cool. It'll run forever because true never becomes false. But you could do something like ask for input. You know, x is equal to input. And if they type a special value, if x is equal to -1, then break. That means stop the while loop. So let's run that. It says cool. Should have said give me a number. Let me rerun it. So it's up at the top. Give me a number. Okay, 10. Cool. 20. Once I finally type in -1, it doesn't do anything. What I do wrong. Brownie points to the first person who spots it. Maybe I heard some murmurings about it. What does input return? It sure doesn't return a number. So I can't compare it to a number. I would either have to make it a float or an int, or if I felt lazy and didn't want to do that, I could put quotes around that. Whatever, you know, either would work. Probably more legit to make it a float. X is equal to float x, so that you could do something with that number. But anyways, I run it and eventually it'll let me out of it. 10, 20, 30, -1. That's what break does. It breaks out of the loop. Okay, so it's not quite really an infinite loop if you provide a break, if you provide a way out. So this is an example of using while true and a break to let the user choose when to exit the program. Do you have to do that? No, you could do what we've been doing before, right? We've been setting a variable repeat equals to y, you know, and then while repeat equals to y, keep looping. They both have the same idea. I think there are times when this might be a better way of thinking about it, but I can't say exactly why I think that. Mostly because it doesn't involve creating a variable beforehand and then doing while based on that variable. Saves one step. Okay. Now let's actually do our recursion, except first we're going to do a while loop that does it in what's probably a simpler fashion. Sum is equal to 0. X, which is our counter, is equal to 1. Our max value is equal to 10. And here I am using variables that are very bad variable names. If they show up in purple, they're bad. Okay, so here we go. Total is equal to 0, x is equal to 1, max counter is equal to 10. While x is less than max counter, total plus equals x, add x to total, and then increment x. If you add 1 to something, it's called increment. If you subtract something from a variable, it's called decrementing. But generally, you only call it incrementing and decrementing when it just goes by 1. If you add 10 or 100 or 20 to it, you know, you're not incrementing it. And then we could do print total. That will calculate the total. The total, the sum total of all the numbers between 1 and 9. Why 9? Because I did less than max counter, so it stops when x is equal to 10. If I wanted to do a better one that actually included the max counter, I would do less than or equal to. Alrighty. And I think that's right. I'm not going to add up 1 plus 2 plus 3 plus 4 plus 5 in my head, but I think it's 55. I'm sure there's some quick way of calculating that. Now we're going to do the same thing with recursion. We're going to call this summation. Summation is a technical term for, when you calculate the sum of a series of values. So define summation. And for this to really work, I need a max. No, I'll be able to get it to work. But we are going to make an assumption. We're going to assume that whatever we are summing is only going to go to 1 to that number, not negative 10 to that number. Our starting point's always going to be 1. So what we need is a total variable. And then we need to check if x, yes sir.
I was swimming through recording.
Yep,
Okay.
I certainly am. Thank you for asking, because 10 minutes ago I wasn't. If x is greater than, no. If x is equal to 0, then return total. I think I botched this. Let's give it a try. Else, total plus equals the summation of x minus 1. Now I'm hoping this works. I'm going to call this one summy because that's a stupid name, is equal to summation of 10. Then I'm going to print summy. We will run it. I hope it works. It didn't. I forgot to return total here. So this one has two ways out, really. And I'll try to work through on the whiteboard after we get it running. So I did just make this change. Well, it returned a 0. That's not very good. All right. I don't usually botch that, so I feel embarrassed. Let's go and Google up recursive summation algorithm. Oh. No. Gonna try that. Don't make that change. Nope. Alright, I'm going to implement exactly what is there in the Google example and feel extraordinarily embarrassed that I had to do this. First time I've broken this demonstration. Alrighty. I think I need to get rid of that. If x is greater than 0, I'm going to change the logic of it, then return x plus summation of x minus 1. Else return 1. Let's see if that works. $56 rather than $55. My hunch was that that was not supposed to be return 1. And that their example is wrong. Okay, fine. 1 plus 2 plus 3 plus 4 plus 5 is equal to 15. Now let's change this to a 5, and that will be our good test. Okay, that is a good recursive algorithm for summing. Let me bring the other one back up on the screen. We're going to set the max counter equal to 5. Which one of these ways makes more sense to you? Probably the loop. Yeah, I initialize a total, I use a loop. Each time I go through it, I add one, or I add the value of x to the loop and then subtract x, and then I print the total. This is the classic summation. There are other ways you could do it where we wouldn't even have to, yeah, anyways. This is the classic summation algorithm as done with recursion. So how does this work? Let's expand this again. Put this up. Pretend that we can. All right, so we call summation, and we pass in 5. So it runs up here. X is now equal to 5. Is x greater than 0? Yay or nay? Yeah, it is. So return 5 plus, and then it calls itself again with x minus 1, which is obviously 4. So it comes back up here, passing in 4. Is 4 greater than 0? Yep. So this is going to return 4 plus the summation of 3. Loops back up here, calls it with 3. So this is going to return 3 plus the summation of 2. Runs back up here. Now x is equal to 2. That's still greater than 0. So return 2 plus underpin. Yes. How much better? Plus the summation of 1. When it comes up here with x equal to 1, since it's greater than 0, still is, but this is going to be the last time. So return 1 plus the summation of 0. Runs up here, passes 0 in as x. Is x greater than 0? Nope, finally. So we return 0. And then it starts trickling back. This 0 replaces that because it was returned. What's 1 plus 0? 1. All right. That return value replaces that. What's 2 plus 1? 3. So that return value replaces that call. Then 3 plus 3 is 6. So that returns there. 4 plus 6 is 10. So that call returned 10. 5 plus 10 is 15. and that returns back the value 15 here. And my pen ran out completely. It's okay if you don't totally get that, but if you do, that's also cool. Hope you see what's going on.
So once it's in the else, it's not going to go back to the x greater than 0?
Right, because it trickled all the way back. Did you see how the 0 got added onto the 1? And then that got returned as a 1, and then that created a 2, and that one got created. So it looks like it's going to keep looping, but it doesn't really, because it just kept calling itself. It kept going, "Rrr, rrr, rrr, rrr," and then it found a return, 0, so back up here. Then it hit that return, it bopped back up there. Then it hit that return, it bopped back up there, hit that return, it bopped back up there, and then it exited completely, if that makes sense. Very good question. Means you're thinking about the way it works. All right, I want everybody to write a recursive algorithm for drawing a tree with a turtle. I kid. But we could do that. We could do that. That'll be the last thing we do today. So let's just scroll all the way up. Did everybody get that?
Mine's not putting numbers.
I had to put a print statement under my summation. Do you have that?
Yeah, the cool part and they give me another part for what the numbers don't show up. And it doesn't give me an error. I run it, doesn't
I did write this stuff in brain, but that's what you're supposed to do.
Something higher than
And
that.
that's just like that. That's what that is.
Oh. It's wanting us to type in a number. Let's type in -1. There it goes. Sorry about that. Stupid prompt. It didn't tell us what we were actually supposed to do. Any other questions?
How are you?
I'm great. That's a good question. Alrighty. So scroll back up to the very top. Let's do import, not import in caps. Import turtle. T is equal to turtle dot capital turtle. Don't forget the parentheses. Now we're going to write a function called tree, or at least branch. Define branch, and it's going to take a value. What branch is going to do is make the turtle go forward that many pixels. Then it's going to turn left. What would be a good branch? Maybe 20 degrees. And then call itself with branch x minus 10. Then it's going to turn right 40 degrees because we went left 20 degrees. If we wanted to go back the way we were going, that's another 20. And then we want to branch off to the right, that's another 20. And then we're going to call ourselves once more. Well, I did something wrong.
Did we? Oh.
One thing, I'm going to lower that to, I don't know, 50 or something, just so I can watch it a little bit better. Okay, that's kind of cool. Not what I expected. Going 0 for 2. Okay, there becomes a point where we need to stop our recursion. So we're going to add an if statement to the very beginning that says if x is less than, what's our smallest branch going to be? Let's say 20. Then do all of this stuff. So we have to tab all of that over. So I just added this if statement. And we may call this lesson done because it, again, didn't work. Excuse me, if x is greater than 20, what is my malfunction? And make it greater than. Because when you go in the first time, x is going to equal 100. So we have to have it allow us to go into the recursive code, which when it said less than 20, well, x was never less than 20 because I passed in 100, so it didn't do a darn thing. Surely you're going to work now. You're still going to draw a spiral on me.
We can't see it.
It's a weird one though.
It's kind of, I feel like a tree.
No.
Cute.
We're probably supposed to make it go backwards after we draw our lines. You go forward, you draw a little branch. When you're done, you go back. So, after all of that shenanigans, t dot back x. Yeah. We call this done. We'll hit this idea again. But really, I want it to work.
Yours looks cool.
I needed to set my angle back to the primary angle one more time.
I'm not even getting that. Mine's not drawn.
Mine's doing some crazy stuff.
I don't know how to work it.
All right. Next time I will have a printout of that code when I walk in here.
Well, mine's not printing it.
Right, I'm going to come around and help now. What it needs to do is it needs to go forward, it needs to turn left and then draw a branch, then it needs to turn right and draw a branch, then it needs to turn left again to be going straight back to where it was originally, and then go backwards. And then I'm just going to stick a return statement at the end so that... Nope. No, I'm not. Okay. Anyways, that should work, and I'm going to walk around and help y'all. Let's make a Dropbox for this. So if you're done, you can bail. All right, sorry. There's the code again. There's the Dropbox. Here's branching. Cool stuff like that. All right.
Cool, thank you.
You gotta put branch in there.
There you go.
Ooh. Maybe I'm just stupid.
Wanted to turn straight up, then you can turn left 90 degrees before you ever call branch. Just make it go up.
Look at that.
Got it?
Yep.
So if y'all wanted to make the tree go straight up, you could do a left 90 before you ever even call branch.
Yeah, I can do a double branch.
Assuming that if your string's already closed, you know what you're doing.
Then you can just increase the scale, right? Decrease the size.
All right, guys. Have a great break.
How do you do that? Don't ask me.
Which part? You want to make the tree go up?
You like to make the, you like to zoom out on it, so we can see the whole tree. Right? Mine was just that way.
See? Really needed it.
All right, let me see.
A double branch to see how big it would go and it ran way on.
Yeah, I wish there was a way to scroll in and out.
Like that, so.
Yours isn't any different than mine, is it? Or
No,
did you just
I
change
ran
it?
it with branch 200 instead of branch
Okay.
100.
Yeah. What might be fun is to make this 0.8 times x. And then do the same thing. Yeah.
I'm cool.
That's kind of cool. Still, if you made it 200, if you really wanted to see the whole thing, I guess we could turn right, go all the way down here, you know, then turn left, and go all the way back up. See, yeah, there you go. Yeah.
You're cool, Bean. A lot of us are cool.
Yeah, that's cool. All right, for those of y'all who haven't closed it, this is kind of a neat change. Change x minus 20 to 0.8 times x. So instead of reducing it by constant value each time, each branch is going to be only 80% as big as the branch it came from. Like that. Kind of neat. It'd be neat to make it to where it could fill like almost a perfect circle with no overlapping. But I'm not clever enough to figure out the values that would do that.